Welcome back, folks. We're going to look at another current divider. It's stated a little differently. I just want you to see it in a slightly different format. They're not quite as tricky as voltage dividers in the way that they're posed, but I've seen this one on some FE exam review material, and I'd like you to see it. I'm going to use it as an opportunity to maybe build some intuition about what's going on with the values, so that we can so that you too can figure out when you make a mistake the way hopefully I figure out when I make mistakes, just by getting a gut feel for what should happen here. Okay, so we're going to start out with the voltage divider, current divider. I think it's the headphones. We're going to start out with the current divider that I have drawn here. And it doesn't quite look like, the three things in parallel and everything. What's important, and I think I said this in the earlier videos, that what's important is that these two branches are in parallel, and we want to understand how this current coming in is going to split between those two branches. I don't care what's pushing that current in. There might be a whole nother circuit around this, but if I know the current going into two parallel branches, then we can apply the current divider. Am I looking for a current based on some other current? Yes. Are these in parallel? Yes. So I pass those two checks. I know I can apply it. In this case, I very deliberately made the two resistors have the same resistance. Okay, so if I want to find IR1, I take the 10 amps, I multiply by the opposite branch resistance, which in this case is the 4 on the bottom here, and I divide by the 4 plus the other 4, the sum of the two branch resistances. Okay, so that's 4 over 8, and that's going to give me 5 amps. Okay, and if this is IR2, and we have 10 amps, okay, now I'm multiplying by this branch resistance, because that's now the opposite branch resistance. And the sum of the branch resistances stays the same, and that equals 5 amps. So when the two branches have equivalent resistances, I'm just going to split it in two. Okay, something similar is going to happen when I have 3 branch resistances that all are equivalent in resistance. I'm going to divide it in 3. If I have 4, I'm going to divide it by 4. So on and so forth. Okay, so this whole business of figuring out when your results are halfway reasonable, this is one way to do it. Okay, so let's draw the same kind of setup. It helps if you have a resistor in there. And of course my undo undid everything. Okay, so if I make this one 4 ohms, and let's bump this up to 6 ohms, and let's keep that 10 amps flowing in just to keep everything else constant. So what's going to go on here? So I'm looking at these going, okay, if they were equivalent, I know it would be 5 amps in one and 5 amps in the other, but they're not equivalent, but they're somewhat close. So I'd expect this one to be, well, it's a lower resistance, so I'd expect the current to be higher. Okay, so I think this is going to be a little bit above 5 amps, and I think this is going to be a little bit below 5 amps. And we can go ahead and do the math on that. You've probably already done in your head. The numbers are nice and round for this one. All right, we have 10 amps, and we're going to get 6 over 4 plus 6, also known as 6 amps. And for IR2, we'll get a similar result where we have 10 amps and 4 over 4 plus 6. And that's equal to 4 amps. Okay, so we can kind of use that as a point to put a bound on what we think our answer should be. If one is much, much larger than the other, if one resistance is much, much larger than the other, then I'd expect a much smaller current. When they're about balanced, we should see them to be about balanced between the two branches. The smaller resistance is going to have the higher current. The higher resistance is going to have the lower current. I think I got that right. Tell me in the comments. Okay, So that's current dividers. If you haven't noticed, things tend to add up with these current dividers as well, and we're going to use that as the basis for introducing Kirchhoff's current law in the next video, and that's our last fundamental law for that we're going to use for circuit analysis. So it's an important one. Okay, so stay tuned and good luck.